we talked about Docker, and we introduced it as a container that started out being on the Linux platform, kind of evolved from the notion of gelling, which included a way to kind of trap a process within the Linux platform. We talked about how that Docker, we talked about some of the differences between Docker and how they kind of evolved from Lexi, right? LXC, if you recall from last week. LXC was a way to kind of isolate resources using namespaces that we talked about with Linux, and kind of evolved into, and Docker built on top of Lexi. They developed their own container. They use something called libcontainer, but principally the same thing. It's a way to isolate resources and isolate processes, right? So that's what Docker is. And so let's talk a little, let's do a quick reminder of some of the other things that we talked about. And from last week, again, we talked about how, if you're the starting point, you have this thing called a Docker registry, right? And this Docker registry right here is essentially a repository, and I know these terms are kind of overused, but just kind of bear with me just a minute. A registry is a repository, or it's a holding unit for a bunch of images, okay? So registry holds images. Often you'll see in the Docker documentation that images are often closely linked to what they call repository. A repository being a base image of some sort, like Ubuntu or CentOS or even Windows, and then what we built yet last week called a Docker file, right? So, and without a base image and without a Docker file, you cannot build an image, okay? So again, so we talked about a registry. It's a place that holds images or repositories. A repository is essentially the image or the thing that you're using, but it includes a base image of the Docker file. Now, it's worth to note these images are read-only. Like once they're built and once they're saved, you can't read them or write. You can only read from them. You cannot write to them. Okay. All right. From there, what on your own Linux box or on your own Windows box, whatever you're using. Remember last week we ran what we call a Docker pull, which is a command, the Docker command followed by the pull argument. This Docker pull went to this registry, right? And in this case, what was the name of the registry? Anyone recall? Right? It was Docker Hub, right? So in the Docker Hub, when we did this from the command line, when we did a Docker pull, it went to the registry, i.e. dockerhub.com, and it pulled the specific image that we wanted and brought it to your local repository on your Linux box. All right. So let's look at that for a minute. So can everyone see my terminal okay? Is that better? All right. All right, so just again, so you can see it, currently I'm just gonna run the Docker command, and if I just do a Docker images, you'll see here in a second, as soon as it comes up. I think I need to reset my terminal. Give me just a minute. Terminate, quit. Yeah. All right. So, when I run this Docker images, I don't have any images in my local repository on my computer, right? But if I were to search for one, just again, we'll run over some of these commands a little bit later on. Excuse me. If I was to search for one, I'm going to search for CentOS just because it's just easy to grab. And what I can do is, and what this is, this searched the Docker Hub registry. That's the default registry. So I searched this Docker Hub.com registry, and I found for CentOS there are several images or several repositories within the repo. That is the same as me doing this. That is the same as me going to Docker Hub. Let me log in, excuse me. That's same as me going here and doing a search here in Docker Hub. Those same ones also appear in when I perform a Docker search. Okay, same exact thing, okay? All right, so I'm going to make this big again so we can kind of get to it. So now when I do a Docker pull like this, it goes to the Docker Hub and it's going to pull back my CentOS image or my CentOS repository, all right? So again, if we were to do a local Docker images, you would see in my local repository, let me clear this so everyone can get to the top. You would see that in my local repository now is this image, okay? And just so you can see it too, in this CentOS repository, you see a lot of times you can come to this repo and you can kind of get some extra information about a few things. So it might be worthwhile to come here and take a look at it. So, Balaji, today we don't have to worry about doing this in Google Cloud currently. And the reason why we're not doing that today is that because we got a lot to cover, and if we were to do that, it would kind of detract. It wouldn't allow us to kind of get to the point that we get up. We're probably about a lesson behind, and I'm trying to make sure we get caught up. Does that make sense? So yeah. But so again, we don't have to do this in Google Cloud, but you're welcome to follow along if you want. All right, so no worries about any of this stuff. Okay, all right. So does that answer your question, Balaji? Or your point? All right, thank you. All right. Not a problem. Okay. So again, so we have this, we went to dockerhub.com and we did pull the repo. So, but what I want everyone to do before we do move on, everyone should have a Docker Hub account. And if by chance you do not have a Docker Hub account, it's going to be important when you go to try different things that you have one. So excuse me. So what I have done is I pasted the link for you all to get the Docker Hub account. So if you click on that link, you can go there and register for one. It just takes a few minutes to do so. So definitely that's something that you're going to want to do. All right. So again, back to this PowerPoint, okay? So again, when you perform this Docker pull, excellent. So we perform this Docker pull from the repo. What happens is it loads it on your local machine, okay? And then this is what's going to happen. And then when I do something like this, clear. And then when I do a Docker run, we'll come back to these commands in just a minute, okay? I just want to show you a principle. Docker run -it CentOS, that should do it. And if I were to open up another tab, again, just so you can see it, and then if we were to do a Docker PS, which brings up images, you would see that a container is running, okay? So here we have this Docker image. And then what we did is that we said run this Docker image in -it means interactive TTY or terminal, essentially. So in other words, give me the command line. So what I did is say run this image in this mode, interactive mode, and I'm not gonna do anything with it. But here you can see when I did the Docker PS, which is the Docker command to bring up containers, not images, containers. And I can see that my CentOS container is running. Okay. Now, if I were to exit out of that container and come back and run that same command, you would see that my container was terminated. Okay. So again, there's a difference between, so if you will, the parts of Docker includes a registry, which holds all of the images. Oh, okay. Not a problem, I guess. Okay, so let's roll back real quick. So when just backtrack a little bit. So what I did was I ran the Docker image, which in turn created a Docker container, right? And I did this Docker PS and kind of lists all containers, okay? So I have a container running currently. Now, containers are very powerful in that, you know, you can stop them and get rid of them fairly easily. So when I exit out of this container right here, I see that let me clear this real quick. I see that there are no longer any containers running. So when I exited it out, it effectively stopped the container from running. That's what I was pointing out. Does that make sense? Yeah, okay, great. So Pradeep said, I think for that we need Control plus Q to come out from running container. You can do it a couple of ways, quite honestly. It depends on the type of container and where you're running it. Like if you're running it in a VM, you got to be mindful that you're running it inside of a VM, and there's a few other things you have to do. But just strictly speaking of the container itself, exit is the command from the command line that gets you out of the container. Right. Okay. All right. So let's talk about a few other things. All right. So again, back to this. So what we should understand now is that there's a registry that holds a bunch of images, or repositories. Repository and image is the same thing in Docker world, okay? A repository or an image is made up of two things, a base image and a Docker file. This repository or image is read-only. Kick, stomp, stop. It's read-only, all right? And what happens is that when you, from your computer, right, when you run this command Docker pull, it takes this entire image or repository and loads it to your local repository. So for every Docker, there's a local repository. Often it's hidden, kind of hidden from me, but it is there. So Balaji asked the question, so what is base image? It is like Linux or CentOS, ISO? Yeah, essentially it's kind of like that, right? Exactly, Balaji. It's like a base image could be an operating system, or it could be an application. So if you would, let's just go to Docker Hub so you can kind of quickly see it. I think you can probably more easily see it here. So in this, notes. So in this, I can come in here and get different operating systems. Let's try another one, CentOS, right? I can do Ubuntu, right? Let's see if there's an OS X in here. Oh yeah, so yeah, not so much as strictly OS X, but they have quite a few different operating systems in here, okay? But additionally, if I wanted to, I could come get an application like MySQL. Or one I think we all have heard of, like HDFS, Hadoop Data File System. Or just put Hadoop, right? Or Hadoop. I can simply go here and grab a container, and then that will allow me to do whatever it is that I can do. So those are different type of base images you can get. Does that answer your question, Balaji? All right, excellent. Okay. All right, so now, after you pulled the base image, right, over to your local repo, here you have it in your local repo. And then what you can do is that you begin to build what they call layers on top of this repo. And these layers can be a bunch of things. It could be that you loaded some file into your container. It could be that you have some kind of software loaded onto your container. And then this container, yeah, excellent, Pradeep. You're absolutely correct. Docker history. That's one way to take a look at them. Another one is Docker inspect as well, right? So, so you can take a look at these layers, which are, again, just represent what's been built on top of the base image, okay? And then what happens is that once you kind of get it to where you want, I can then take it and push it back and then what happens, everything I've added now becomes a base image or repository image in my registry. All right. So these are some of the different things that you can do with it. But the main thing I want you to get here is some basic understanding of when you see registry, when you see images, when you see container, that you understand the nuanced differences between them all. Okay, are there any questions? Any questions? Jerome, the overhead of Docker compared to VM, it is much smaller. Generally, they say that you lose anywhere from about 2 to 3% of processing power when you're using containers. For VMs, you use somewhere in the neighborhood between 5 to 15%. Not a problem. Balaji, probably the reason why, if you instead of running just Docker images, if you do pseudo Docker images, that should take care of you. And Balaji, you just want to he wants to try things as we kind of go forward. Not a problem there, Balaji. So that's not a problem. Okay. All right. But again, I'm primarily demonstrating for those who want to follow along can. You can do it that way. Right. Okay. All right. So any questions? Not a problem there, Balaji. Any questions? Not a problem, Splitter. Go ahead. All right. Watch these. So the OS is when this base image is downloaded, I don't think you can see the exact path that it's in, but let me see something. It's like a hidden directory. Let me see. Where is it? CD dot. That's the machines. It's in the hidden. The answer is it's in the hidden directory. I can't quite remember where that hidden directory is to actually see the raw Docker image, but it's a hidden directory. It should be fairly known. It should be pretty easy to find. I can't quite remember where it is, and I can find that out if you want me to. So we got a couple of questions. Can I please explain layering again? And I'll do that then. But I think this local registry question is fairly easy to do. Here in a few minutes of Padai, we're going to build a local registry, and I'll show you how to do that. Okay. All right. Now, Smith, back to your question. You said layering. Let's go back to that, right? So essentially, the point I'm making is any image that you pull from the registry is going to be your base image, right? So if you would, when you pull it over here, this becomes your base image. So you kind of look at when you pull it, that really goes away for the most part. And then what this really becomes is your base image. Right? This is your base image now, okay? And then when you run the container, you're going to do various things inside the container. It could be that you load files inside of the container. It could be that you add software to the container. It could be a variety of things, whatever you would normally do with a computer. But every time, practically the way that it works is that each layer represents some kind of what they call a commit. All right. Each layer represents a commit. So I could have did a bunch of things. I could have added software and files and a few other things, but until I do this commit, that's when it becomes a part of this layer. And then the next commit would be a part of the next layer. and so forth. So ultimately, you'll just kind of keep building until it does what you want it to do. And then from here, then I can take all of that, all the things I've committed, and then push it to a registry. And then that in turn becomes a base image. Does that make sense, Smita? All right, great. All right. Let's move on to the next thing. All right. So we talked about the relationship between this in an image. So Smita asked, is it something like you download image, make changes, and upload your very own? Yeah, exactly. So you download an image, then if you want to be able to kind of use the thing that you build again, you push it to your own Docker Hub account. Correct. That's exactly right. All right. Okay. So, well, layering isn't that entire process. Layering is strictly this notion of adding something to your original repo or your original image. So in one case, yeah, I got it. Yep. All right. All right. So now that we understand the differences between a registry, a container, and an image. Again, images are read-only. Containers I can read and write because it's kind of what I'm working on, right? Containers use image as the base, okay? All right, so now that we understand that, so let's start with the one on the left here. This, this is a Linux box, okay? So for Linux, again, we talked last week about, this notion of a kernel. We talked, Yodi, I'm sorry, so, I'm sorry, Yodi asked a question. Isn't images like the condition in which that system currently is? I'm not sure if I understand the question, Yodi, before I move on. It sounds like you're asking, is it like the base condition or the starting status? Yeah, gotcha. So for containers is what is running, right? And I think. Oh, okay. I got you. Yeah, no, I think I see what you're saying. I mean, an image is just like I think probably closer to what Pradeep said. It's this notion of, it's like a tarball or a zip file that has all your stuff that you need in order to run it. Right? That's how I would say it. I mean, so an image is kind of like this starting point, that a zip file or a tarball that has everything you need to run whatever you're running within that tarball or within that zip file. So I see that relationship. Does that make sense? All right, excellent. Okay, so any other questions on images, containers, and registries? We're good? All right. All right, so now that we understand, one more question. Can we modify an image at our end and make it as our copy? Yes, you can. You can do that, and we're going to talk about that a little bit later. All right. All right, so now that we understand the relationship between a container, image, and registry, let's talk a little bit about the software, okay? The software that makes all this work together, okay? So looking at a Linux box, You have, again, for the most part, Docker and containers only work within a Linux environment. Just kind of follow what I'm saying. Don't jump to any conclusions right now. Just kind of track along with me. Docker containers currently only work within a Linux environment. I'll talk about what I mean here in a minute, okay? So in this Linux environment, you have a kernel. We talked last week about the Union FS. Union file system is kind of what allows you to do different versions or different branches of a current file system and kind of build other layers on top of that so that you can have different types of file systems to include like NFS, ext4, whatever. You can have different types on top of this Union file system. On top of these file systems are these control groups, all right? We talked about yesterday, or C groups as we refer to them, right? And C groups is a way to kind of isolate resources. All right, now, resources and processing as well, okay? Now, here, what we have is this Docker engine. This Docker engine is the API for Docker. Docker engine is the client for Docker. I'm gonna go back to control groups. Okay, all right. Docker engine. Let me finish this thought real quick. Docker engine is the API. It's the client, and it's the daemon for Docker. A daemon is a process that runs in the background. That's what a daemon is. Okay. So when we say Docker engine, we're talking about, for the most part, all the things we need to run a container on a particular machine, okay? That's a Docker engine, all right. Now, last week, Balaji, to answer your question, we talked about these namespaces, okay? Don't forget, a namespace was a way to restrict what processes that run have access to. So I have a network namespace. Anything that's kind of network related will run under that namespace. So it's a way to kind of isolate processes. It's a way to isolate different types of underlying resources. So a process running in a network namespace may not have direct access to changing user information, right? Because there's a user namespace, and anytime a process runs in that user namespace, it has access to the user namespace resources, right? So these namespaces are a way to isolate resources and only kind of make available the resources that it has access to. So just a practical example, a lot of times you build these namespaces when you only want certain processes to have access to like 2 gigabytes of memory. You want it to only have access to 1 core, right? 1 core being 1 CPU associated with your machine. You only want it to have access to a particular network. And all that can be done by creating these control groups. These control groups allows you to isolate resources. Does that make sense, Balaji? And the reason why you might want to do this, again, is so that not one application that you run or not one process eats up more resources than you want it to eat up. Because there's nothing worse than a rampant application or a rampant process that's killing all your memory, eating up all your disk space, and so forth. And it happens. All right? So what happens is that Docker engine is the Docker application that is used to control the API, the client, and the Docker daemon. Again, the daemon is just a Docker process that runs in the background. That's all it is, okay? So, Balaji asked a question. So Docker engine is developed using which language? I think it's a combination, quite honestly. I do think that primarily there's a notion of Go, and if I recall correctly, there's some C in there as well. C++. But if you were to go just real quickly, because I'm kind of curious too, you were to go to Docker GitHub. Because again, it is all open source. If you were to go to any of these code bases, I think you can kind of get to the core of what it's built in. Yeah, so you have some Go language is a part of it. Yeah, matter of fact, I think most of it is in Go. Yeah, Go language. That's the name of it. All right. All right, any other questions before we keep on? Not a problem. All right, so again, you have this Docker engine, and this Docker engine is what's used to run these individual containers. It kind of provides the infrastructure to run these, okay? Now, to execute on a single container, you simply use the Docker command. And that will allow you to start, stop, add properties, etc. for one container. But sometimes you need to control containers in groups, right? Or kind of spin up 10 containers to do 10 different things as part of your application. In that event, you're not going to see red here, I'm sorry. You need Docker Compose, right? And Docker Compose is Docker Compose, it allows you to run on multiple machines. So with Docker Compose, you don't have an option to commit, but you don't have to because there's an actual, if you would, a build file for Docker Compose. So you can tell it to build all these different things, and then you can take that YAML, which is a type of language or a type of configuration for the Docker Compose, and you can save that and share that, and then that way anybody can use it to build your Docker. So there's no need to quote unquote Docker commit for that. All right. All right. So now, so over here, this is your base. This is kind of what we're going to base everything else from going forward, okay? All right. Any questions about Docker on Linux? All right, great. All right. So now we have Windows and OS X, okay? How does Windows and OS X implement Docker? Okay, so just like Linux, Windows and OS X both have a kernel, which handles all the managing of the resources below, hard drive, network, all the hardware, etc. Okay. But what Windows and OS X do for you, in order to use the containers, it essentially has to spin up a VM for that to work. So when you say Docker run here, it just kind of spins up a container on Linux. When I say Docker run on Windows, it spins up a VM. And in each VM, there's a container that's running. When I run Docker run on Mac, by default, it uses the Mac OS hypervisor, but I can make it use VirtualBox or a few other ones. But nonetheless, it's going to spin up a VM and it's going to have a container inside of that VM. That's how Docker works on Windows and in Mac OS. And then what happens is essentially it creates a Linux environment inside of that VM. It's the same stuff that's over here. All right. So what's the difference? The difference is that Windows and Mac both uses a VM and they kind of build a Linux box inside of that VM. All right. Any questions about that? All right. Now, so here's the nice thing. So Akesh asked the question, if we have to configure a VM separately to run containers on Windows, how does it prove to be cost effective? If you're referring, when we say cost, you're referring to money, it's because everything is free and open source, right? So Docker on Windows comes with the Hyper-V VM already. It's already there. So there's no further cost, i.e. money, that you'll have with that. Okay, so essentially, let me clear this screen. So yep. So again, on your Windows box, this is how it works, or OS 6 for that matter. You don't have to worry about a kernel because the kernel is already there. There's a Windows kernel that operates the Windows the way that it needs to work. Okay, you don't have to do anything else. Hyper-V automatically comes with your Windows machine, just like Mac OS Hypervisor comes with Mac machines. You don't need to do anything else. Those already come with the Windows OS and the Mac OS X respectively. Okay. So Docker knows that. Docker knows that Windows has the Hyper-V, and it knows that Mac has the Mac OS Hypervisor. So nothing you need to do. So when you go to Docker, when you go to download Docker from the site that it's in, which is you can download you can go to here and download the community edition. So when you go to download any of these types of Docker instances, essentially what you're going to end up having is it knows how to use the Hyper-V and the Mac OS hypervisor already. So no need to dedicate any special environments, none of that. It's all there. Okay. Now, within the scope of so once the VM is started, again, when you just simply run Docker run image name, whatever it is, CentOS, whether you're on Windows, Mac, or Linux, if I was to run that command there, it would simply, it would kick off on Linux, it would kick off a container only. On Windows, it will kick off a VM first, and then it would build the container inside of that VM. With Mac, it would kick off the VM first, and then it will build the container. It will run the container inside of that VM. That all happens automatically. Does that make sense? Not great. Nope, not a problem. Okay. Now, because you can run Docker in VMs, what you can also do is create VM hosts for Docker using Docker machine. Yes, yeah, Balaji, you run sudo, not su. Su is a command, but sudo is the one you want to run. All right. So again, because I can run Docker in VMs, what I can do is I can create my VM host using Docker machine. So let's kind of point that out, okay? All right, so back to my terminal. So in this case, I am on OS X. Can you hear me? Sorry about that. All right, good. Okay, so here's what I was saying. I was saying that so for Windows, there's Hyper-V. That's the hypervisor that Windows uses. When you run Docker, it builds the VM first, and that VM that it builds is a Linux VM. And inside of that Linux VM are the individual, the container that you ran. Right? So does it answer your question, Jerome? We're good? Okay. Okay, gotcha. Oh, no. So the container itself, so the actual container itself will run whatever it's supposed to do. So like I think the actual version of Linux that it runs, like in the VM, is like something called Alpine, if I recall correctly. Alpine Linux VM is, I think, is what it is. But if I download a CentOS box, the container will be a CentOS box. Or, as you mentioned, if it's IIS, it will be an IIS container. All right. All right. Any other questions before we move on? So Balaji asked a question, how do they download different versions of CentOS? You have to really kind of search for it. That's the ultimate answer. This is if I can go back to Docker Hub. So like if I wanted CentOS 6.7, you see I can go here and download a specific container that's version 6.7. Or if I wanted to get the latest version, you see here that in this case, it tells you the version that it is. And then the other thing that you can do is that as a part of this tag, so just so you can see it, So I could do something like this, and I think this should, I think it'll get it for me if I do it this way. Yeah, let's do that. Let's go 6.6, see what happens. Yeah, see, that tag allows me to pull the version for the Docker or whatever else I want. But the way that I know that is by going into the Docker hub and kind of reading the documentation, because it kind of tells you what's available. And yes, and this version very specifically is in this Docker. I should notice it doesn't have anything before 6.6. So if you want to find 6.5 or 6.2, that may be a little bit more challenging. All right. All right. Excellent. All right. Now, okay. So let's go back to this here. So here's what we're going to do. In this, I'm going to show, because again, I'm on this is the OS X. This is a Mac, and I'm going to kind of show you the relationship between Docker machine, the Docker command, that way you can see it. Okay. All right. So if I were to do this, oops, sorry. And what I did is the Docker tab. Tab is a way in the Unix-based system to kind of see what commands are available. But here I did is Docker tab, and I see that I can run this something called Docker Compose, Docker Credential, OS X Keychain, and Docker Machine. Okay. We're talking about a lot of this is specific to OS X. You won't have to worry about it, but it's a way to kind of add Docker credentials in Mac, what's called a keychain, which is essentially a list of username, passwords, just for lack of better terms. That's kind of really secure. But nonetheless, I have Docker Compose, and Docker Machine. We're going to talk about Docker Compose next week. All right, so here, if I were to do a Docker -, this pulls, Docker -help, this pulls up a list of arguments that I can use with the Docker command to perform different options. Principally, with Docker Machine, again, which is a command, I can do the -help. Then I have a list of commands I can run with the Docker Machine command. Okay. Again, Docker Machine is the tool that's used to control virtual machine hosts. So what I'm going to do is I'm going to create a Docker machine. Okay. So I'm going to tell it to create one and to create a Docker machine. And in my case, I wanted to use VirtualBox. So I'm going to tell it the driver is going to be VirtualBox, right? Two, there's one for Amazon Web Services. There's one for Google. There's one for, I think, like DigitalOcean and a few other ones, that when you run Docker Machine and you run this command, it allows you to create a VM on those other cloud type platforms. Okay, but here I'm going to create. In this case, I'm going to create one on VirtualBox on my local machine, and I'm going to name it Simplilearn. Okay, so I'm creating a Docker machine or a Docker Docker container host, and I'm creating it using VirtualBox, and I'm going to name that Simplilearn. Let me add some characters behind it, just kind of build uniqueness, right? So I'm going to do that. I'm going to press enter, right? And it's going to go through some process. So Balaji, you asked a question, and if you give me a few minutes, well, the driver is this. I'm gonna type it into the text. PI dash project dash what's it called? Console name. Right? It's something like this. And that console name, oh, hold up. I messed up on that. Give me a second. There you go. Yeah. Then the second one is right. So essentially, whatever your console is in Google Cloud, that's what you would have to do. Okay. Yeah, not a problem. So that's how you do it. All right. Now, again, just so you all can see it, I'm bringing up VirtualBox, and you see that now that same, clear. That same machine that I created, again, so here's what I just did. So again, we talked about how that Windows and Mac OS, they build VMs for Docker, okay? But essentially what I did is I took, using Docker Machine, I can build a Docker host that, or if you would, a VM dedicated to running containers, right? So, and if I show you, I'll show you what I'm talking about. Give me a second. So here I'm gonna do a Docker dash machine, and I'm gonna do an ls. And so I have two Docker hosts. In my case, but the one I just created was this one called Simplilearn. And note, it's a VM that's running on my OS X box currently. Okay. Now, what I can do in here, I can do Docker machine SSH simply. And what this does is very similar to how you kind of SSH or RDP to other boxes. I'm going to, by running this Docker machine command, I'm going to access the command line from this machine. So now I'm in this Simplilearn machine, right? If you were to do a uname, you would see that this uses a Linux kernel, and specifically it uses boot to Docker, which is a lightweight version of Linux that has Dockerish type commands, Dockerish type dependencies and commands you can run. Okay. So again, all I did was create this VM. So Docker Machine allowed me to create this VM, into that. And so in this way, we're only using Docker only without necessarily having to use all the putties and SSHing and all those different things. This might be a benefit to doing that. But you very well could SSH into it in the way that you would do that. How would you know? The question was, how would you know the IP to run? Oh, excuse me. Oh, I'm sorry. Exit. Here, I can see my IP address associated with this particular work instance. So I could SSH into it the normal way, but Docker Machine gives me a nice, easy way to do it without going through all that. All right, now you can get into the machine. All right, any other questions? Does that answer your question, Smita? Yes, that's it. Yeah, a catch. An IP is automatically assigned to the machine dynamically. Something you don't have to worry about. To the VM, excuse me. And there's a way, there's different things, like you can be as specific as you want. You can assign it a particular IP, a port, all kind of stuff, right? I mean, the list goes on on how you do those kind of things. But but by default, it just kind of assigns an IP to it automatically. So like, just so you can see it again, Docker machine create -- help. And what this does, it'll show you all of the arguments you can pass the create command. Oh, sorry. Oh, these are all the different things that you can do. You can kind of set up memory. Swarm is a way to manage VMs that we'll talk about again next week. You can set up IP addresses, different labels, environment variables, all kind of things, right? So, but nonetheless, I just want to kind of point it out to you that last command that I ran, Docker machine create -- help. This is the argument, and this -- help provide. It'll show you all the arguments you can pass for this other create. Okay. All right. Any other questions? So Balaji, you asked the question. You said there are some tabs like active, arrows. I think you mean errors. Are you referring to where I am, or I'm not sure where you're talking about when you say that? When you say there's some tabs, active and errors. I'm not sure if I understand, Balaji. So if you can provide some clarification, hopefully I can answer your question. All right. Okay. So while you're writing that, Balaji, I'll go ahead and kind of move on. So this Docker machine. So again, all I did was create a host. And then here, if I wanted to build different VMs, oh, I'm sorry. So now I'm in that Docker host that I created via Docker machine. I know it because I see the user, which is the Docker user. I'm on this host, okay? So what I can do here is I can do a Docker search for CentOS again, just to kind of see it. And if I wanted to add it here, matter of fact, let's add this one here. This way we can see it. This is a Scala version of CentOS. So I'm gonna say Docker pull that version of CentOS, right? And it's gonna take a few minutes to kind of download and get. Hopefully it's not that big, I don't think. And these are the different layers that is downloading. So when they built this image, it's like 4 different layers that it has to download. All right. So now, if I were to do a Docker images, I would see that I have this Registry CentOS Scala. And it's only in this Simplilearn VM. So watch this now. Just watch carefully. I'm going back to my local machine, my Mac OS X. And if I do a Docker images here, guess what? I don't see that one here. This image I just downloaded. So again, this Docker image is a way to Balaji, it was just a totally random image container. The only point was to show you that what I do here in the Docker machine that I created doesn't affect what I do. Oh, excuse me. what I have on my local machine. That's totally it. And so, and Balaji, but to answer your question, Scala is a type of language. So all that means is that they loaded all of the Scala dependencies to run that language in a CentOS box. All right. All right, great. All right, so we see that this Docker machine is different than the Docker. So, okay. So I'm going to come out of this Docker machine and I'm back on my Mac. Okay. So let me clear this so we can have it. All right. So what I'm going to do next is this. So by default, when I run this Docker command here, it is only for my machine, for my Mac, in this case, my OS X. But what if, when I run this Docker command, I wanted to affect a specific Docker machine that I created? How do I do that? So the way that I do that, I can run this command. I can eval is a way to build, is a Unix command that allows you to build other commands. Essentially, is what it is. So what I'm going to do is I'm going to run this eval command, and I'm going to pass it. So Balaji asked, do we need to pull from the machine, the local machine? No, we don't. That is not the same thing as a registry. Okay, we're going to build a registry later on. But the only point of me showing you the Docker machine is to show you how you can separate things from your local environment. Right, okay? So again, what I'm doing now is I'm getting ready to build a command that will allow me to link what's going on in this one specific terminal to what's going on that Docker machine that I created, okay? So what I can do, I can say Docker machine, and then I'm gonna run this environment variable. And actually, before I do that, I can't remember the Docker machine I created. So give me a second, sorry. There it is, okay. So I'm gonna say this environment, and then I'm going to do this, okay? So what this is doing is that it's saying, build this command that's simply going to link this Docker machine to this specific terminal, okay? So I'm going to go ahead and press enter. Oh, sorry, we got a quotation mark there, okay? Now watch. So now when I do Docker images, it shows what was in the Docker machine that I created. So now I can do this from my native terminal without having to go to Docker machine SSH, without having to go inside of the Docker machine that I created and do a Docker images. It's right there. They're linked, okay? Now that's only for this one specific terminal. If I go here and try to run that same command, notice it's still on my machine, and it pulls up my machine's local repo. This command only works for the terminal that you run it in. All right. Okay, any questions? All right. So somebody asked questions. So if we have a Linux box, we just install Docker and get going. But if we have non-Linux machines, then we need to use Docker machine command. Is that so? Not necessarily, because the Docker machine allows you tighter control of the VMs that Docker runs on. But if you don't have a problem with the default, it's not a problem. All right. And so the other thing that Docker Machine allows you to do and again, there's a lot of them, so I'm not going to really get into a big, long statement, a big, long discussion about it, but I have a link here that I'm going to share with you. Let me see if I can find it real quick in a minute. Docker Machine drivers. Okay, this probably one is worth you having. All right. I'm gonna give you. I'll explain the links in just a minute. Give me just a minute. Docker Machine drivers. So again, Docker Machine allows you to just have a VM or VM capable. Matter of fact, here's a list of them. There, I sent you 2 links. So that second link brings you to this one, and these are all the different places where VMs can run. Every single one of these are VM based, and so what I can use is those drivers, right? Those drivers, and I use VirtualBox in my case, but the point being, you can use all those different types of drivers that we see here, and create container VMs on those different platforms. So why use Docker Machine? Typically, if I got to go between different environments like Google Cloud, my local AWS, then maybe the answer is I use Docker Machine versus the Docker command, because that gives me greater control of the VMs. But even once I get into the VMs, right, and what I mean by get into the VMs, is here. Now from here, I can run the Docker command once I'm on the host or in the VM, right? So Docker Machine, it allows me to control the VM host that I'm creating, but still I need to get to the host to run the different types of containers. All right. So let me see if I can come up with one more example. So let me get rid of all this stuff. So here I have this is my Windows box, Windows, right? And on my Windows box, I can do, on my Windows box, I can run Docker, or I can run Docker Machine, right? So why would I use Docker Machine? Docker Machine allows me to create VMs, VM hosts that run containers, right? VM hosts, and this could be on Google Cloud, right? It can be on Amazon Web Services Cloud, whatever. It doesn't matter. But it allows me to essentially create these VMs for that. Whereas with a Docker, essentially what it allows me to do is kind of just deal with containers on my local Windows box. Or principally the same thing here. You know, if I were to run Docker on this particular machine, it would allow me to create my because once it's up and running, then I have to run that Docker command. Make sense? All right. Any other questions? All right. All right. So that's the Docker machine. We talked about the Docker engine again. The Docker engine includes the API. It includes the if you would, the difference being, if you want to look at something, the Docker command. Oops, make sure this clear. The Docker command, for the most part, that's all the stuff that the Docker engine, Docker machine, the Docker machine, okay? All right. And Docker machines, generally, they're used to deal with VMs, right? I want to kind of stress that point. All right. So that's that. So now we understand that we have this Docker command, which kind of allows you to do the Docker, affect the Docker engine. Docker machine does just that, affects the Docker machine. And we talked a little bit about Docker compose, which allows you to maintain or affect multiple containers. Okay. All right. So now that we understand a little bit about the architecture and the software, let's kind of move on to a few other points. Okay. Now, Docker, again, the starting point is always going to be like this Docker file and some base image. We talked a little bit about it last week, and we created a Docker file and we built one, right? In the example that we gave, let me go to my slide deck. There you go. All right. So we talked about this, and in the Docker container, we had several key directives, right? You recall we had from was one of them, which tells it the starting image, but there's other directives as well. Okay, there are other directives as well. So again, you had this build, and in this build, you have this Docker file, which is the starting point, and you have a base image. So you have from, which is kind of where it starts from. It says this is the base image. But additionally, what you can do is that you can identify who the maintainer is as well, all right, whoever that may be. But then you have this other commands. You can run like shell commands here. And this shell tag allows you to do just that. It allows you to run shell commands. It doesn't matter which ones they are here, but they allow you to run shell commands. And particularly for Linux, it's pretty powerful. And then you have copy tag. Again, all this is in a Docker file. This copy tag allows you to copy source files and source directories to add to your build. Okay, this is what that copy allows you to do. This add command copies the files and kind of points to URLs that you can get a hold of. What is going on my computer? It's just moving forward. All right. So in this case, it's saying add a tarball to the op directory inside of my container. That's all it's doing. Okay. Now this run tag, it allows you to run, again, some Linux commands to affect how your sometimes, which in this case, yum is a way to manage dependencies. RPM is a way to install some software packages. And then in this case, the last one here, I told it to go into to change directly to the op directory and then create a link from the tarball that I installed. That's all it did. All right. Additionally, I can set environment variables by simply typing env, and so these are all tags within that Docker file. And lastly, this command file allows you to kind of set the default application. So if there's something default you want to run, you can set it here. So the difference between this CMD and this run, you can put a series of different things that you can run through, commands you can run. This CMD kind of defaults whatever you want to run by default when you run the container itself. That's what that is. And then we did this last week as well. Then from there, we do a Docker build -t, and we're going to name it something. And then you're telling it this period says in this directory, or you're going to list the specific Docker file that you want it to run to. Okay. Any questions about the Docker file? Okay. So again, whenever you build a image, this is probably the good starting point. You want to have a Docker file that you can build yourself. But however, typically when you download an image, there's no need for you to have direct access to that Docker file unless you're going to change it to some degree. All right. Any questions? All right. Let's go ahead and move on to this other key point, because somebody asked about how can we build our own local registry. Okay. So building your own local registry. All right. So we talked about it in Docker Hub, how it's a registry. And we talked about how that we can build this registry and it's what holds your images. So again, you can do that, but then the other thing you got to think about when you do that, you have to think about, why do I want to do that? Is there a reason for that? Because you're going to have to consider security issues, access control. How do you verify that the image is safe by digitally signing images and with different hash generators and so forth. So there's a lot that kind of goes into it, but nonetheless, you can create one. Again, we talked about how registry is a service used to manage and distribute these images. But what happens is that we can take these registries and that we build and just simply load our Docker images into that, right? So the way that works, I think we talked about this already. Docker Hub is your default registry, right? But it's just as simple as changing the command that you're running to. So let's go ahead and create a registry just so you can see that. So I'm going to create a registry here. And so let me, I already did it. Let me go into my directory, Docker machine, SSH Wyatt. This is a Docker machine that I created for this class. So if I do a Docker images, I see that I've already downloaded the registry container, right? So if I were to do something like Docker pool registry, tag 2, it will pull that specific registry, all right, or that specific container. So what I'm going to do is I'm going to run that container. Let me make this full screen so that way we can follow along. I can't see your questions, so just give me a minute and I'll get through it. Then I go back to review if there's any questions. Okay. So again, I'm creating a private registry. So what I can do here is I can kind of say Docker run, and this -d, this means run in the background. It's like detach, right? And then what I'm going to do is I'm going to put this -p here, and that kind of tells me my port. So I'm going to map this machine, this Wyatt machine, this user at this machine. I'm going to say this is my VM or my host port, and this is the port I'm mapping to in my container. Okay, so this creates a map between your host and your container. All right, and so I'm gonna add another command, and I'm gonna say restart always, and then I'm gonna name it my container registry. All right, and then the image I'm gonna run is registry 2. All right, so this Docker will kick off my registry, and it has all the registry stuff that you need, and it's going to run this registry on port 5000, and this -- restarts allows me to restart the registry once I log out. Okay. Oh, hold up. What did I do? Oh, sorry. It was 2 dashes. Okay. All right. So now if I do a Docker PS, I see that my image is running that I named the registry 2. Okay. And there it is. So I see that my registry is now running. So now what I'm going to do is I'm going to pull an image from Docker Hub. Okay. Matter of fact, let me check something out real quick. Images. I had worked through some of this already, and I want you all to kind of see what's going on, right? So that RMI means remove images, not containers, images. So when I do a Docker images, I see I no longer have that. Okay. So let me clear this, get you back to the top. Let me see there. Make sure that there aren't any questions. All right, good. All right. All right. So again, I'm still in my Docker VM or Docker machine. So next, what I'm gonna do is I'm gonna pull Ubuntu from the Docker Hub. Okay. And not only am I gonna do that, but I'm also gonna tag it the same way when I pull it as Ubuntu, and I want to put it in my registry container. Again, don't forget it was mapped to port 5000. Localhost is the default IP address assigned to it. But here I have localhost 5000, and then what I'm going to do is I'm going to just tell it I want it as Ubuntu. So now you see that it downloaded the image, but where it just again, I'm still in Docker Wyatt, and if I do a Docker images, so to do that, it took it and put it there in my local repo. Okay. Now, what I'm going to do is I'm going to delete that Ubuntu image again. Okay. So when you see it, it's not there in my local repository. But again, here, this command, I loaded it in my registry. Okay, but what I'm going to show you is I'm going to pull it from my registry and put it back in my local repo. So in order for me to do that, I just wanted to show you that in my local repo, I don't have that Ubuntu. Okay. Now, so what I'm going to do is I'm going to go do a Docker pull, but instead of just kind of not putting anything there, just kind of putting the image name, I'm going to tell it which registry I want to pull it from. So I'm putting it from that same registry, and I'm saying, bring me back that Ubuntu image. Okay. Let's try this again. Sorry. Here's why it didn't happen in there. So I'm gonna grab this again. Docker images. It's on my local repo. You see it here. What I forgot to do was push it. Excuse me about that. So what I'm gonna do from there is I'm gonna do a Docker push localhost 5000 and Ubuntu like that. And it's pushing from my local repo to the registry. So I forgot to push it. Sorry about that. So now that I pushed it, I see that in my local repo I still have it. So I'm gonna remove that from my local repo. And you see that in my local repo it's gone. So now when I go back to pull it from my local host, you see that it grabbed it, and now I have it back. All right, where are you? Right here. I have it right here in my repo. Okay. So that's how the registry works. So, Balaji asked the question. The NN is right. It's used for combining commands together. That's all it's for. To do this one and then do this. And thank you, Smith, for helping answer that question. Okay. Yeah. All right. So is that for the registry? Let's see. Let me see if I can get a PowerPoint here. Registry. All right. So what we did here is that again, so we can see it. Our starting point was we downloaded the registry container from GitHub. That was the first thing. Then next what we did is that the next thing that we did was we started the registry container, right? And we did that by this command here. And I'll post it in the we did it by running that command, right? That's how we started our container on port 5000, our registry container on port 5000. Once we started the container, we downloaded image from Docker Hub. So Balaji asked the question, how the registry is set using the above command. Because the registry is already in the container, all I did was in that -P, that tells it which port to map from the container to my local machine. The -D means just kind of running in the background. And then the dash name, the dash name is what I use to name the container. Don't forget, you got images to name it registry. And then I told it to pick up the registry image version 2. And when you do that, that runs that causes that registry container to run. So Balaji asked the question, is there any port-related constraint like Tomcat application? No, there's not. You might, like, I think for the ephemeral ports, you might have to do something different if I recall correctly. Like the ports like that's above, like, I think, what is it, 35,000 or something like that. You might have to do some different mapping, but for the most part, it still should work. So Smith asked, so we are creating our own registry and making it run in a container. Yeah, so that's what we're doing. We took our own registry and we're running it in a container. Exactly what we did. Yeah. All right. And then and this is what we did. We downloaded this. We downloaded I think Ubuntu from Docker Hub, and then from there we pushed the Ubuntu container to registry. That's all we did. All right. So just to point out, there are other Docker registries, just so you know. Docker Hub is probably the primary one, but Google has a version. AWS has one. Quay, although I haven't really dealt with them, they have one. Then you can create your private registries, right? So, I mean, different ways to do this. Matter of fact, where I work, we have our own private registry as well. And in that way, you know, we try to keep everything private that way, okay? Let's see what else. This is probably something else that we need to do too. This Docker login -- username. So by default, when I run this when I go to pull and push, when I push to Docker, I need a Docker login for that to work. So that command will allow the system to know who I am, right? And then and this is what we were talking about earlier, you know, how do you create these images? Essentially, what you're going to have to do is you're going to have to create a container, and then you're going to commit it to a particular Then you're going to have to commit this container name, Java, and this is what you're going to commit it. When you put it in Docker, this is going to be the name. And then when you push it, it pushes out to your Docker Hub repo. Balaji, that is the username that you will use in this case. The one at Docker Hub, absolutely correct. All right. We talked about Dr. Pool already. We talked about deleting too. You saw me do this where you can do the Docker RMI. Now, I want to point something out too, and I think it's worth mentioning. So if I did a Docker PS, I see that the Docker PS, it lists all my Docker containers that are running. So here I see that I have one Docker container running. One Docker container running. So here, let's see. So when I did the Docker images, I see that I have this Docker image. So if I wanted to remove that Docker image, I just do RMI, Docker name, meaning image name. It's asking me to do a force for that delete. And then when I did that, you see that the name of that image is no longer in my local repo at all. Okay, clear. Now, here I have this Docker PS at this container running. Now watch this, just so we can see it. I'm telling it to remove this container. And this container I knew was there because of when I ran the Docker PS, I saw that these are the containers that are running. So when I do that, it says this: you cannot remove this container because you're running it. But if I didn't care, I could just simply do something like this, and then that removes the container, right? All right, so let me see. All right. So Vlad asked a question. So if we run the RMI command and delete the repository or image, can we restore that image from repository? Yes, but you have to do a Docker pull again. That's all.
Hey, want to become an expert in cloud computing? Then subscribe to Simplilearn's channel and click here to watch more such videos. To nerd up and get certified in cloud computing, click here.